What you see depicted is a simple circuit to illustrate how the logic gates come together to work. This is an electronic system that switches on a security alarm if a burglar approaches a safe at night. So let's see how these logic gates work together to give a desired output. The circuit is connected such that if it is dark and someone approaches, the alarm would sound. So in the dark, if someone invades or enters uninvited, then our alarm should go off to prompt whoever is inside of someone's presence in there. So then how does it work? So let's see how it works. A light sensor is connected to a NOT gate. The light sensor will produce a high output when there is light, and a low output when it is dark. The output of the light sensor will then become the input to the NOT gate. When it is dark, the input to the NOT gate will be a low, so the output of the NOT gate is going to be a high. The output of the NOT gate will be one of the inputs to the AND gate. The pressure sensor or switch will give a high output when it detects a rise in the pressure or force as a result of the presence of someone. Both inputs of the AND will be high, and so the output of the AND gate is going to be a high. The output of the AND gate is not strong enough to turn on the alarm. It is therefore connected to a relay. The output of the AND gate turns on the relay, which in turn turns on the circuit containing the alarm. So I hope you caught it. Basically, if it is dark, our output is going to be low for the lights. If it is dark, then it means the input to the NOT gate is going to be a low. And because the NOT gate inverts the input, the low is going to be a high, and that is going to now be the input to the AND gate. And if the pressure switch should sense the presence of someone, it is also going to give a high output. So it means we have two high inputs to the AND gate, and so the output of the AND gate is going to be a high, which is going to be fed to a relay. And the relay is basically there to turn up things because the output of the AND gate is not high enough. So it sort of like amplifies the output of the AND gate, and that is going to trigger an alarm to prompt us of the presence of someone. So let's see how this is explained using a truth table. The truth table of the NOT gate is simple. It inverts the input. A zero output will give us a zero input will give us an output of 1. An input of 1 will give us an output of 0. So then we know that the output of the NOT gate becomes one of the inputs of the AND gates. And the pressure switch is tied to the other input of the AND gate. In a situation where both are zeros, the output is 0. When either of them is 1 and the other one is 0, the output is going to be a 0. But when both are 1s, the output is going to be a 1. And that happens when there is darkness and there is a presence of someone. When there is darkness, the light sensor is going to give a low output, which is inverted by the NOT gate and becomes a high input to the AND. Together with that of the input of the pressure switch, we get the output of the AND gate to be a 1. So this is how gates are combined in whatever combination you want it to be to give a desired output. Diode. What is a diode? It is a semiconductor device that acts as a one-way switch for current. It allows current to flow in just one direction and prevents the flow in the opposite direction. When a diode is connected in one way to a voltage source, it has less resistance, which allows current to flow. But if it is connected in a different way, it has a very high resistance, so current is unable to flow. So what are these modes of connection we are talking about? One is called the forward bias, and this is where current flows. A diode is forward biased when it is connected such that the positive terminal of a cell is connected to the positive terminal or the anode of the diode, and the negative terminal of the cell is connected to the negative terminal of the diode. If it happens that way, resistance is diminished or reduced significantly to allow current to flow. In the reverse bias mode, the positive terminal of the cell is connected to the negative terminal of the diode, and the negative terminal of the cell is connected to the positive terminal of the diode. This kind of connection results in high resistance produced because if you look at the inner workings of the diode, it actually consists of two semiconductors connected, a p-type and an n-type. So the p-type is where we have a lot of positive charges. The n-type is where we have a lot of negative charges. So if the positive terminal of the cell is connected to the negative terminal of the diode, and the negative terminal of the cell is connected to the positive terminal of the diode, what happens is that the charges end up neutralizing themselves, creating a huge gap, which is usually called a barrier, producing high resistance, and so current is unable to flow when a diode is reverse biased. One particular type of diode we are really interested in is the light emitting diode. That one emits light when current flows through it. That is, when it is forward bias, light is emitted. But when it is reverse bias, where no current flows, no light is emitted. Hope you enjoyed it. See you in the next video.